So hey guys, today we are looking into the problem Leetcode problem 713, and the problem statement is we have to find minimum number of operations to make a subsequence. So uh, in this problem we are given two arrays. First is target and another is array, and we have to make our target array to our given array. So uh, this question we have the given time constant for this question is for us is n log n. We have to solve it under n log n. So for this problem statement, we have to first know another topic known as longest increasing subsequence. So usually longest increasing subsequence is done in n square time space using dynamic programming, but we have to solve this in n log n. So firstly, we will quickly go through the that problem, longest increasing subsequence, and then we will be going through this problem. So suppose we are given an array, we have to find the longest increasing subsequence in this array. So in log n time, n log n time. So what would we do is, uh, firstly we can have a dry run here. So suppose I have given this array 1 7 8 4 5 6 minus 1 and 9. So one by one I will try to put our values try to put our index values in an array in an increasing number of way. So suppose we take the 1. We are on index 0 and we take the 1. We will check if 1 is since our array is empty, so we will put 1. Then we are on index 7. Then we will check our current array. Then we will check if 7 is greater than 1. So yes, 7 is greater than 1. So we will write 7 now. Next we are on 8. Now we will check if 8 is greater than 7. So yes, 8 is greater than 7. We are on we add the 8 to our array. Now we have our array 4, our number 4. So 4 is less than 8. So what can I do is I will iterate back to the place when 4 is greater than the last element, since we are storing it in the sorted order. So I will go through, since 4 is less than 8 and 4 is also less than 7, but 4 is greater than 1, but 4 is greater than 1 here. So what I will do is I will add 4 to this location, another location. So suppose I have created another array using this 1 4 here and 8 as it is. Now same about 5. Since I cannot add 5 to the first index, I have to add the 5 to the second index. Since I have either have two choices. If I have to add 5 in the first index, I would have to add it like this. I would have to add it after here, whose length will be less than length equals to 2. And another option is I can add 5 here. The total length of the array would be 3. So what I will do is I will add 5 here in this array. I have added 5 here. Now same about 6. We add 6 here. Now we have minus 1. So we will check for the both of the arrays if minus 1 uh, if we can place minus 1 at which position and where. So firstly we will iterate through. Here we cannot, here minus 1 is less than this, minus 1 is also less than this, minus 1 is also less than this. So for this array we can put minus 1 at 0th index. So we have to create new array. For the another array, minus 1 on here, minus 1 on here, minus 1 on here, minus 1 on here, we have to put minus 1 on 0th index. So we have to finally create another array for minus 1. So we have created minus 1. Now we have 9. So 9 have two options. Now we have 9 have two options. Either we can place it here or here. So but the length in which I can place 9 is more in this array. So I will place 9 here. So this would be my maximum increasing subsequence, longest increasing subsequence. here. But we have a problem in our solution. Our problem in the solution is we have to iterate over the all of the arrays that we created throughout the day. So what we can do to bypass that is, so what we can do to bypass that is, if I am putting any array, if I am if I am to put any if I am to put any integer to any index, uh, so I don't have to look into the so the only value I have to check for that is the largest value for which is greater than this. If the value is smaller than this, I can replace it easily with the another value. Since the previous of the whole array remains the same, so I don't have to worry about the previous of the array. I can simply insert it here, because for all the element which is greater than the for all the element which are greater than the current element here would be after this, and we don't have to look into it. If the element is lesser than this, then I can replace this, because the future element would be which are in this would also be greater than this. And if an element is comes which are greater than this, I can simply put it in the end of that. So I can create it somewhat like this. Firstly, I have 1, then I have added 7, then I added 8. Now 4 is less than 8 and 4 is less than 7. So I will find the position where I can fit the 4. So 1 here, I will find the I found that I can put 4 in this place. So I have put in 4, and 8 remains the same. So so all the elements which are between which are greater than 7 would be greater than 4 also, but all would be greater than 4 also. That's why we are using it here. If an array comes which are greater than 8, so I will simply put it here. So this array will contain my maximum size of the longest increasing subsequence. It will not be the actual longest increasing subsequence, but it would surely give me the longest increasing LIS size. Yeah. So where will be? Now if I try to add 5 after 8, let me erase this. After 8, I put it. Now we have 5. So what I will do is I will find the index where I can put 5. Since I can put 5 here, I will replace this 5. Now the length of both of the array is same. So I will replace it with the lowest one array, which I can replace it to 5. Now the number is 6. I will add 6 here. Minus 1 comes. I will find the index where I can put minus 1. I can put minus 1 here. Foreseeing the possibility if the number greater than minus 1 comes, where I can put that. So this array remains sorted all time. Then finally 9 comes. 9 greater than 6, I can put it here. So maximum length of my longest increasing subsequence is 5. So how I can use in this problem? So we have given that the target is unique, has unique character. So what I can do is I can map all the values of the target corresponding to their indexes, because I want to find the target inside the array in the same order: 0, 1, 2, 3, 4, 5, 6. I want the sub array of the target. So I want to find the sub array, any sub array of the target inside the array, such that it's in the increasing order. So since the element inside the target are unique, so what I can do is the index in which they are stored will also be unique, and the index would be increasing. So what I can do is I can map the target with the ARR. I can map the target with the indexes and find the longest increasing subsequence corresponding to longest increasing subsequence here, this corresponding to this array. So what I can do is, suppose I map 6 to 0, 4 to 1, 8 to 2, 1 to 3, 3 to 4, and 4 to 2. I will first go to every element and check 4. 4, does our map contains 4? Yes, our map contains 4. 4, does our map contains? Yes, our map contains 4. 4 has value 1. So I will put 1 in our array. Next, I will iterate to 7. Does our target has 7? No, our target doesn't have 7. So I will move to the next term. 6. Does our target has 6? Yes, our target has 6. It's on the 0th location. So I will find the 0th location here. I can put the 0th location number sorted array according to LIS, our LIS code. So I will replace this with 0. I can write this like this. 0. Now our next element is 4, 7, 6. Next element is 2. I will find 2 since 2 has size as index 5, and I will put the 5th index here, right here, since 5 is greater than 0. So 5, 5. Now our next element is 3. I will find 3 here. 3 is at 4th index, so I have to find the 4th index position here. Since 4 is less than 5, I will place 4 in this position. Now our next element is 8. Since 8 at second position, I have to find inside it our array second position, where I can put second position. Since I can put second position here, so I will replace 4 by 2. Now our next element is 6. 6 has 0 position, so I have to replace 6 by 0. And now 1. 1 has third position, so since 3 is greater than 2, I will add 1 here. So our final array is 0 to 1, and length of this array is 3. So this is the longest length of the common subsequence of our target array inside our array. So I have to find the how many number of element I can add inside this array, inside the target array to inside the ARR array to make it equal to target array. So that answer would be common longest increasing subsequence, length of target minus target length minus longest increasing subsequence. Because that many number of elements are remaining to be found in correct order inside our ARR. So this is the C++ code of our problem. Firstly, we map all of the array inside, all of the array of our target with their indices, since all the elements of our target are unique. Now we will iterate for each of the element inside the ARR and find its position if it's contained, and find the position inside our the array which we created, and find the maximum length of our maximum length of our array, longest increasing subsequence array, and we return the target size minus x. Okay, thank you guys. That's it for this video.